All right, before we start off with talking about the formulas, what is the difference between surface area and volume? There we go. So surface area is all the area on the outside of the shape. Volume is the stuff inside the shape. Yeah, that's probably the best way of looking at those two concepts. So we look at the surface area of a sphere. That's basically what we have here. We just have a big ball. And everything, the volume and this surface area, there's only one variable. Can you guess what that variable might be? There's only one variable involved in both of those equations. Nope, that's not a variable. The radius. So when we look at the surface area for a sphere, it's 4 pi r squared. It's like 4 circles thrown together. 4 pi r squared. And then the volume, hey, remember yesterday we talked about the volume of pyramids and cones?
Yeah.
How is the equation for the volume of a pyramid different than the volume of a prism? What's the only difference between them? You guys remember? Okay, the volume for a prism was the area of the base times the height. The volume for a pyramid was 1/3 the base times the height, right? Well, when you go from surface area to volume, it's similar. Not the same, it's definitely similar. See the 4? We're going to take 1/3 of that. So that becomes 4/3. Well, what is the units that we throw in with volume? Cubed. So it's 4/3 pi r cubed. That's kind of one of the things that you might be able to do to kind of help you remember and kind of make that connection there. And that's it. That's our two formulas. So silly number 1. What are you asked to do on number 1?
Find the surface area.
Find the surface area. What's the formula for surface area?
4 pi r squared.
4 pi r squared. Volume, or sorry, surface area. 4 pi r squared. Yeah, 4 pi. So Keanu, what's my radius?
14, and it would be square, you get 196.
So that's 4 pi times 196. You give us 784 pi. Which is squared. Now again, guys, leave your answer in terms of pi unless otherwise instructed. Alright, so Amber, that's one of the beautiful things when you're in a math classroom. We don't have to beat our head against the wall, leave it in terms of pi. Alright, take a look at number 2. How is number 2 different?
Do it.
So how's it different than number 1? What do you mean the opposite? Going backwards. So I now have the surface area, and I need to get back to my radius. So let's start off with this. And this is kind of one of those skills that's really important when you guys get into your sciences, especially a class like ICT, chemistry, and physics. So let's call the surface area A. And we know that A is 4 pi r squared. What variable are you asked to solve for on number 2? You gotta solve for r. Okay, guys, this is an algebra 1 problem. Start solving for r. What do you do first? What do we have to get rid of first?
Yeah, get rid of your.
Okay, the 4, and what else can I get rid of with the 4? Pi. So, A divided by 4 pi equals r squared. Now what do I have to do to solve for r? It's square root. So r is the square root of A over 4 pi. Now before you freak out, let's let's just do this together. Now we have R. R square root, what was my A?
256
So 256 pi divided by 4 pi, so what happens? Pi's cancel out. What's 256 divided by 4? So R is the square root of 64. So R is 8.
So, really you did the same thing, but like when I did it just in my head, like thinking like strategically.
Yeah, no, Sam, what you're doing in your head is exactly the same thing we're doing here, we're doing here with structure. Okay?
I just divided it by 4 with the square.
Divided by 4. And take the square root of it.
So on a test, will we be deducted strategically instead of
Algebraically? No. Solve the problem, that's all I want. So look at number 3. What are we being asked to do on number 3?
I don't even know. Find the volume.
Find the volume. Let's do it. What is the formula for the volume of the sphere? No, it's R cubed. Okay. So volume is 4/3 R cubed. All right, this would be super easy if
We knew what the
we knew what the radius was.
Oh, shucks.
I don't know what the radius is.
case.
Well, let's assume that this point right here is the center of the sphere. So what would you call this length? That would be the radius. What would this be called here?
It's only 16 is the radius.
16 is not the radius. The radius is 8 radical 2, and I'll show you how we get that here in just a second. What could I use? First of all, what type of triangle is created here? Isosceles and right triangle. What do we get to use with right triangle? Pythagorean theorem. Therefore, r squared plus r squared is equal to 16 squared. So 2r squared is equal to 256. So r squared is 128. So r is the square root of 128. And believe it or not, 128 can be broken down. What perfect square goes into 128? I need you guys to think. Is there a perfect square that divides evenly into 128? 132 is not perfect. 16?
8.
8 is not a perfect square, Sam.
64.
Oh, 64. Now, Cheyenne, you said 16, right? And that does go in there, but the largest one that goes in is 64. And 64 times what? That's 2. And therefore, R is 8 radical 2. Yes.
Couldn't we use the other thing with use for like you have a 45?
Yes,
90?
this is a very good count. I was about ready to go there with this. And I'm glad you brought that up. Guys, if you notice, well, you said that this was an isosceles triangle, correct? That's an isosceles right triangle. So what type of special right triangle is this? 45, 45, 90. If it's an isosceles right triangle, then both these angles have to be the same. Therefore, it makes it a 45, 45, 90. No. Again, you know that that's a right angle. And these two sides are isosceles. Then you know that these two are the same, and these two have to add up to 90, therefore they are 45. So yeah, you could use the special right triangles 45, 45, 90 and know that the side length R is 16 divided by radical 2, which takes us to A radical 2.
Which just easier and simpler, wasn't it?
Well, if you recognize that, yes, it can be easier and simpler. So remember I told you guys R is going to be 8 radical 2. That's how I did it. But the Pythagorean theorem will guarantee you that you get there the same way.
I like to shorten it easier.
That's fine. Okay. Now, guys, I know this might look easier, please, but this is actually going to be a little bit more of a challenge. And I think it's really important we pay very close attention here. All right, so we know that our radius is 8 radical 2. We have 4/3 pi. That's 8 root 2 cubed. I'm going to warn you right now, this is not going to look pretty. Now I'm going to pause here. I think it's just really, really important that you just stop and think for a moment. Let's go to a scrap page. And I want to do this 8 radical 2 cube. What does it mean to cube something? Yeah. Well, what does it mean to actually cube something? Let's go back pre-algebra. If something's being cubed, what are you doing with it? Multiply by itself 3 times. So that's 8 radical 2. 8 radical 2. 8 radical 2. Now, multiplication. What's 4 times 3? Okay, so tell me what's 3 times 4? So does the order that I multiply matter? So why don't I group these and just do 8 times 8 times 8 times root 2 times root 2 times root 2. 64 times 8?
It's 512.
It's 512, okay. So that's how we got the 512 right there. Oh, that was really bad. Well, now, take root 2. What is root 2 times root 2? Which is 2. So this right here actually gives us the 2, and we're left with 1 extra radical 2. 512 times 2? So 1,024 times root 2. Alright. I didn't say this was going to look pretty. I warned you guys that from the beginning. Alright, so here we are. So we have 4/3 pi times 1,024 root 2. Okay. What's my next step?
Type it in there out.
No. What's my next step? What do you think, Mason? Even if you're wrong, what do you think we should do next? Take a stab at that.
Times the 4/3 and
Yeah.
the
Now,
1.
the best way to do that is to simply multiply by the 4. So we get 4,096 pi of radical 2 all over 3. And that is our simplified answer. And I know you guys are laughing at me like, okay, that's simplified. Technically, that is the simplified way to write this answer. 4,096 pi radical 2 over 3. Now at this point, you go to the calculator, type it in, and we're done. All right. Hey, look at number 4. We've seen this before. Okay, we've seen problems just like this. How do you find the volume? Oh, this one's a little tricky. I did not realize that here.
The volume of the surface.
Find the volume if what?
The surface area.
Okay.